In this video, we're going to talk about graphing linear inequalities. Graphing a linear inequality is exactly like graphing a linear equation, except they're a little bit more fun because we get to do some coloring. So if I'm looking at this one, x is greater than or equal to 1. I'm going to graph this as if it were an equation. So I'm going to actually graph the line x equals 1. I only need to think about, okay, when we were graphing these on number lines, if we had greater than or equal to or less than or equal to, we had a closed-in circle. If I had less than or greater than, I had an open circle. So how am I going to show that on an actual line? Well, here's how. If I have greater than equal to or less than equal to, I'm going to do a solid line. Because I'm saying I want to include all of the solutions that get as close to that line as I possibly can, and include that line. If I have a less than or a greater than symbol, I'm going to do a dashed line, similar to my open circle on my number line. Again, I want everything as close to that line as I can get, but not including the line. So I'm going to do a dashed line. This one, because I have greater than or equal to, is going to be a solid line. And so I graph this exactly like it were an equation. Remember, x equals 1 is our equation where for every single coordinate, the x-coordinate, for every single point, the x-coordinate is 1. So that gives me my vertical line. So I'm going to go to 1, and I'm going to draw a vertical line. Now the inequality says I want all of the points that have x values that are greater than or equal to 1. Well, if I'm looking at this graph, all of my x-coordinates greater than or equal to 1 are going to be all on this side. So this is the fun part. This is where I get to color. So I'm going to shade everything on this side of this line, because any point over here has an x-coordinate that's greater than or equal to 1, and that's exactly what we want. The next example, y is greater than -3. So I'm going to graph this, again, if I was graphing the equation y equals -3. But this time I have a greater than sign, no equal to sign. So I want to get as close as I can to that line, but I don't want to include it. So that means I'm going to have a dashed line. Remember, our y equals -3 equations, when we were graphing those, were horizontal lines. So we go to -3, we do a dashed line. And again, I want all of the y coordinates that are greater than -3, so that would be everything above this line. So I'm shading everything here. This one we have our x and y, and again, we still graph this as if it were an equation. So I'm graphing the actual equation, x minus y equals 2. I have a less than or equal to sign, so I know it's going to be a solid line. The next thing I have to decide is what's the best method for graphing this line. Because I have x and y on the same side and constant on another, that's my standard form. I'm thinking it'd be quickest to use x and y intercepts. So my x-intercept here, remember x-intercept is on the x-axis, so that means I have a y-coordinate of 0. Well, if I plug 0 in for y, this is going to go away, and I'm going to have x is equal to 2. So my x-intercept is going to be 2, 0. My y-intercept then means that I'm sitting on my y-axis, which means my x-coordinate is 0. And if I plug 0 into my equation, I have -y equals 2. I don't want -y, though I want y. So y is going to have to be equal to -2. Then I'm going to graph that point. We do have a solid line, so I'm going to draw a solid line through those 2 points. This one's not as exact as the other one. I couldn't tell where the coordinates were greater than or less than that number because I have both variables. So I'm not quite sure where to shade. I'm going to choose a test point that's not on my line. So I'm going to test with point 0, 0. It doesn't have to be that point. That one's easiest because we like zeros. But I could choose 1, 1 or -1, 1, really any point on either side of the line. I'm going to test 0, 0 in my equation. So I'm going to plug it straight into my inequality, and I'm going to say 0 minus 0 is less than or equal to 2. Simplify this side up. We have 0 is less than or equal to 2. Is that true? Yes, 0 is less than or equal to 2. So my test point worked. If my test point works, that's the side of the line I'm shading. If my test point does not work, then I'm shading the opposite side of my line. So since 0, 0 worked, my shading is going to be everything over here. So my solutions to this inequality are any ordered pair that lie in this shaded region or on the line. This one's in slope-intercept form. So again, I'm graphing the equation y equals 2x minus 4. This one's less than, so I know this is going to be a dashed line. So I'm going to start by going to -4. Then I'm going to use my slope, and I'm going to go up 2 over 1. Again, dashed line. And now I have to decide where to shade. Again, I'm going to choose 0, 0. It's a nice, easy point to work with. So I'm going to test in my inequality the point 0, 0. If 0, 0 works, if 0, 0 is a solution for that inequality, then that's the side I'm going to shade. And if it is not a solution, then I'm going to shade the other side. So when I plug that in, I get 0 is less than 2 times 0 minus 4. When I simplify this side up, I get 0 is less than -4. 0 is not less than -4. This did not work. So because 0, 0, that test point did not work, I'm shading the opposite side of the line. So that means I want everything on this side. So again, everything in this shaded region and getting as close to that line as I can. All of those ordered pairs are solutions to my inequality, but the points exactly on the line are not points to my are not solutions to my inequality. 5, on school nights, you are allowed a maximum of 40 minutes total to surf the internet or text your friends. Write an inequality and describe the different amounts of times you can spend surfing or texting. So my total maximum is 40, which means I know I'm going to have less than or equal to 40. I'm doing 2 activities, either surfing the internet or texting my friends. So any combination of those becomes my inequality. So the number of minutes I surf the internet plus the number of minutes I text has to be less than or equal to 40. Then we're going to display our answer on a graph. I'm going to change, my x-axis is going to now be s, my y-axis is now going to be t. Remember, we need labels. So down here, I'm going to say number of minutes surfing internet. And over here, I'm going to say number of minutes texting. Again, it would be easiest to find my, in this case, S and T intercepts. So my S intercept is going to be when I don't spend any time texting, I'm just going to surf the internet. So that's going to be 40 and then 0. I'm going to choose to go by 5s down here. So that would give me that point there. Then if I don't spend any minutes surfing the internet and I spend it all texting, my t-intercept would be 0, 40. So again, I'm going to go by 5s. And then I'm going to connect those 2 dots. I do have my equal to sign, so I want a solid line. Now, I can have all of the numbers on, all of the different ordered pairs on this line, or I can be less than that. So, quite clearly, I'm going to be shading inside this triangle here. I can't surf or text negative minutes, so I only have my positive axis. So any combination of surfing and texting in the shaded region or on the line would be okay. I just can't be on the other side of the line. This one I'm going to have you think about for tomorrow. what is the relationship between the graph we did in number 5 and the solution of this right here?